Hey guys, today we are learning about the second derivative. That's right, there's more derivative than one. And so to start us off with learning about what the second derivative tells us about, let's remember what the first derivative tells us about. So the first derivative tells us about the slope of f, specifically like the slope of the tangent lines to f. Right? So when we know if they tell us that f prime is greater than 0, then what that's telling us is it's telling us something about f. It's saying that f is increasing. Right? And similarly, if f prime is less than 0, it tells us that f is decreasing. And so if they give us some fact, like f prime of 2 equals 4, what that means is that f is increasing at x equals 2. It's increasing with a slope 4, right? And if we drew that out on f of x might look something like this. At x equals 2, it would have a slope of 4, so it would kind of look like this around x equals 2. Right now, this kind of steep slope might be up here, it might be down here. We don't really know, but what we do know is that at x equals 2, f is increasing. Right? So the big message here is that f prime tells us about the slope of f. What does f double prime tell us about? And so f double prime is actually going to tell us the same things, except it's not going to tell us about f. It's going to tell us about the slope of the graph of f prime. All right, so this is going to be really hard to kind of visualize for a while, but we'll be doing a lot of examples. And so if it tells us that f double prime is greater than 0, we're just going to kind of do the same thing we did here. All right, so if f double prime is greater than 0, then f prime is increasing. All right, so f prime tells us about f double prime tells us about f prime. And similarly, so f prime is decreasing. And we'll see what this all means in a second, but let's just look at this example. So if f double prime of 6 is equal to negative 2, what does that mean? It tells us that f prime is decreasing. It has a slope of negative 2 at x equals 6. Right? So if we drew that out on a graph, we'd be looking at, it could tell us that the graph of f prime of x at x equals 6, it has a slope of negative 2, so something kind of like that. Right? I'm just looking at a little snippet right now. But let's do a few more kind of graphical exercises here. So let's try to draw a function where the second derivative is positive. Right? And so we're going to be drawing here, we're going to draw f of x, not f prime of x. So notice right here I was drawing f prime of x, and so this fact told me something about f prime of x. Right? The fact of the second derivative. So let's remember what f double prime of x being greater than 0 means. It means that f prime is increasing. Right? So if this is f of x, if the graph I'm drawing here is f of x, what would f prime be here? It's the slope of kind of this segment, right? And so the slope of this segment would be something like, the slope would be equal maybe to negative 3, right? It's kind of steep down. So if we want f prime to be increasing, that's what f double prime of x being greater than 0 means. If we want f prime to be increasing, this slope needs to be increasing, right? So let's say maybe it's negative 1/2 now, or negative 1. Right, my values for my slope are increasing. That's what f double prime of x being greater than 0 means. It means that f prime is increasing. Let's say maybe my next slope is actually a 0. Right, and let's keep increasing the slope. So let's have a small positive slope now. M equals 1, and then maybe something like this. M equals 3. And so kind of what we can see from here is that, well, when f double prime is greater than 0, we have f prime is increasing, and what that really shows us, this is a concept from chapter 1, is that this tells us that f double prime, when f double prime is greater than 0, it tells us that f is concave up. Right? Similarly, let's look at one where f double prime of x is less than 0. Now let's remember what that meant from here. It meant that f prime was decreasing. So again, if I'm drawing the graph of f of x here, what does my graph of f of x start off with? It starts off with a slope of about 4, right? 3 or 4, something positive. And so I want my slope to be decreasing. That's what f double prime being less than 0 means. So let's do a slope of, this looks like 1, and then a slope of 0. And let's keep decreasing the slope. -1, and then maybe something like -3. And so what we can see here is that when f double prime is less than 0, we know that f is concave down. And so what I really wanted to show you from these two graphs here is that here's an example of a function f where f double prime is greater than 0 the whole time, right? But notice on this graph that f prime is less than 0 for that part of it, and f prime is greater than 0 for that part of it. For the last part of it, it's equal to 0 in the middle. And similarly down here, we can have f prime being greater than 0 for this part, and then for this part, f prime is less than 0, right? And this one, f double prime is less than 0, f double prime is greater than 0, right? So we can have different values of f prime on the same graph, even though f double prime is constant throughout the whole time. It's always greater than 0. And so just to actually write that fact out, so f double prime being greater than 0 means that f of x is concave up, and f double prime of x being less than 0 means that f of x is concave down. So if you're a little bit lost, kind of what we're really looking for to spot on the graph at this point, when it tells us about f double prime being greater than 0, we know something about f of x. We know f of x is concave up, right? That kind of idea from chapter 1. And similarly, f of double prime being less than 0 means that f of x is concave down.